Here in section 6.3, we're going to start learning how to do adding and subtracting with these polynomial fractions. Adding and subtracting is a little more challenging than multiplying and dividing, and because it's a little bit harder, we're actually going to break it down into two sections. 6.3 is going to be about the easy case, where the denominators match, and we're also going to learn a little bit about building common denominators in 6.3. And then next time in section 6.4, that's where we're going to be adding and subtracting the full-on different denominators, more complicated problems. So the easy case where the denominators match, the good news is that even though technically this is a new type of thing, it's fractions with variables in it, I bet you already know what to do when the denominators match, like in this problem here. Pause for just a second, write down what you think the answer is, and see if it matches what I'm about to get. I bet you were right. I bet you got 5 over x plus 1, because adding fractions when the denominators match is really easy. You just add the numerators. Here's a slightly more challenging problem. Give this one a shot, see if you get the right answer, and then press play again. So if you add your numerators together, 5x plus x is 6x, 7 plus 11 is 18, but if you stopped here, and that's where you put your answer, you missed a really important thing. And that is, you are expected to always reduce fractions no matter what. It shouldn't have to be part of the directions. You should know that automatically without it being said, that fractions need to be in lowest form. In this case, what that means is you have to factor out a 6 from the numerator and then cancel the x plus 3. And please don't write your fractions 6 over 1. That's a childish mistake. It's way too advanced a level of mathematics now. 6 over 1, you should just write 6. So if you got it reduced all the way down to 6, you've learned this key idea that you're supposed to always reduce fractions no matter what. Now, here's a subtraction problem, but again, I bet you already know what the answer is. Take just 1 second, write it down, see if it matches what I get. 9 minus 4 should be 5 over 2x plus 1. Exactly. Here's one that's a little more challenging. Give this one a shot and then press play. So here, 10 minus 7 makes 3. Hopefully you didn't stop here. The lesson I just mentioned a second ago about always canceling. Here you should factor the denominator into x plus 2 times x plus 3 and cancel the x plus 3's. Be careful. If your denominator is 1, you don't have to write the denominator. But if your numerator is 1, that's a fraction, and it has to be a fraction in your answer. So 1 over x plus 2 cannot be turned into just plain x plus 2. That's not the same thing. That's a pretty basic mistake. Don't make that kind of basic mistake. And then here's a slightly more challenging subtraction problem. In fact, the thing that's challenging about this is that the second fraction's numerator has more than one piece to it. It's got 2 terms up there. And my suggestion is to make sure that you do this problem as safely as possible. I suggest you start by distributing in, distribute, spelled with an I, distribute in the minus sign first. Now the first fraction, it won't be changing any. We're not distributing a minus sign to it. But the second fraction, since you're subtracting x plus 2, you're distributing in a minus x and making it a plus 2. And then it's an addition problem. Then you can combine your like terms. Negative 3x minus x is negative 4x. 2 plus 2 makes 4. And then we're stuck at a step where there's an easy way and a hard way. We just a couple of times had to factor and reduce, so make sure you factor and reduce. But what exactly do you factor? Well, the denominator's easy. That's x minus 1 times x minus 1. And you might be tempted to write that x minus 1 parentheses squared. But for cancellation, it's actually better to write it this way. So it's kind of a a lazy way of writing it, but it's actually beneficial in this case. And in the numerator, what do we factor out up there? Do we just factor out a 4? That would leave negative x plus 1. Well, it might be a little easier to do the reducing if we factor out a negative 4. Then it's more obvious that x minus 1 cancels x minus 1 because it's a perfect exact match. So those are a couple of pieces of advice. Don't write it as parentheses squared, and factor out the minus 4, not just the 4. And that advice is meant to make the problem a little easier to do. So, for adding and subtracting fractions where the denominators already match, you'll probably find you're really good at it pretty quickly. In fact, the end of the problem where you reduce the fraction, that's probably the hard part. Actually getting the thing into one fraction is fairly easy. So then we start to talk about the topic that's going to lead us eventually to section 6.4. We start to talk about the idea of common denominators. And this is a pretty tricky topic. And the reason why this is a tricky topic is there is an easy way to do the problem, and it's not worth it. And then a harder way to do the problem that's actually better. Let me explain what I mean. Think back to elementary school. Remember back in elementary school, if you had to work with these three fractions here, adding them or subtracting them or something, and you needed to build a common denominator, one way of building a common denominator, sort of the easy way to build the common denominator, is to just multiply all the denominators together. In this case, that would give you a common denominator of 192. But you probably learned in elementary school very quickly that that was not a very good way to do the problem. Getting three fractions where the denominators are all 192 and then having to reduce at the end, that's really rough. You probably learned in elementary school very quickly to produce something called the lowest common denominator, which in this case, for 6 and 4 and 8, that's just 24. So the lowest common denominator was a key idea in elementary school. Any old common denominator can be brute forced by multiplying your denominators together. The lowest common denominator requires more thinking. You've got to plan ahead and imagine more and think about the next couple of steps. But it's really, really worth it. And the same thing will be true when you're working with variables. Here, with these two denominators, we could theoretically get a common denominator, brute force, by just multiplying the two denominators together. Or we could do things in a more sophisticated way and get the lowest common denominator, which in this case is just 9x to the 4th. So, just like in elementary school, you have a sort of a bulldozer technique where you just multiply all the denominators together, and a more sophisticated technique where you work with a smaller denominator, and that is definitely what you want to try to do. So the kinds of homework problems you'll have to do here in 6.3, they're going to be a little frustrating because what they're going to do is they're going to tell you, here's a couple of fractions, don't add them, don't subtract them, just rewrite them so that their denominators match. And it's going to feel weird because all of your training from back in elementary school is after you get the denominators to match, then you add the numerators or subtract the numerators, depending on whether it's an adding or a subtracting problem. So you're going to have to sort of stop yourself halfway through the problem. Get a common denominator, stop. And here's how that works. We know from what we were talking about just a second ago that the denominator we're going to eventually get here is going to be 9x to the 4th. But just knowing that that's the denominator you're going to get, that's not enough. You have to know how to get there. What do you have to do to get from 3x to the 4th to 9x to the 4th? And what do you have to do to get from 9x to 9x to the 4th? You have to multiply by something in each case. So here, from 3x to the 4th to 9x to the 4th, you had to multiply by 3. And from 9x to 9x to the 4th, you had to multiply by x cubed. And here's a really important rule for fractions. If you multiply something in the denominator, you better multiply the same thing in the numerator. So if I multiply the denominator by 3, I better multiply the numerator by 3 also. If I multiply the denominator times x cubed, I better multiply the numerator times x cubed also. So, first of all, figure out what the common denominator is. Secondly, figure out how to get to the common denominator. And then the third thing is, do the same thing in the numerator that you're doing in the denominator. It sounds more complicated than it is, but it is somewhat complicated. This is not an instantaneous, easy thing like the first half of what we were doing today. So here's a more complicated example. Pause the video, get out a piece of paper, try it yourself, and then press play. See if you get the same thing I get. Okay, one of the tricks that may have been important for you to do here, and if you didn't think of this, this is a super important trick, is that you need to factor the denominators first. The numerators, it's not so important. You can leave them. If they can be factored, you don't have to factor them. But the denominators, you need to factor them first. So here, this one's denominator on the left factors x plus 3 times x minus 2. And this second fraction, when you factor its denominator, that's 2x minus 1 times x plus 3. Once you've got them factored, it's a lot easier to figure out what the common denominator is going to be. And at the same time as you're building that common denominator, you can also see what you're going to have to multiply by to produce that common denominator. So, what you look at is compare the denominators. Notice they already have something that's common. They already have an x plus 3 in both of them. And then notice the thing that's different. This one has an x minus 2, this one has a 2x minus 1. And in order to create a common denominator, you're going to be multiplying by something, and the something you're going to be multiplying by is whatever the denominator doesn't currently have, because you're trying to make them match. So when you're comparing the two of them, the one on the left here, it needs a 2x minus 1. That's what it doesn't have currently. And this one over here on the right, it needs an x minus 2. That's what it doesn't have. So when you build a common denominator here, the common denominator we're going to have is going to be 2x minus 1 times x plus 3 times x minus 2. And do not multiply out any of this. Don't multiply out the numerator. Don't multiply out the denominator. For right now, here in 6.3, just leave everything factored. And this part, some students stumble on this quite a lot. Don't reduce these fractions. That was kind of the whole point, is to get these unreduced fractions that have the same denominator. If you reduce them, you're sort of undoing everything you've just done. So leave them looking just like this. Next time in 6.4, we're going to do the step that you know comes next. You know right after this we're going to be talking about taking these two fractions and either adding them or subtracting them. But we don't do that here in 6.3. We do that in 6.4.